Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello everyone, welcome back to another video. So in this video we're going to create an RPN calculator, a reverse Polish notation calculator. So let's get started. I'm going to use the IDE C-Line. You can use whatever IDE you want as long as it's Rust because we're going to be creating that calculator in Rust. So let's get started. So let's create a new project here, Rust. I'm going to use the binary application. Let's go. I'm gonna call my thing something. I'm gonna call it CDTK RPN, basically Codotaku reverse Polish notation. Let's create an application, and we get hello world. There we go. We can run this, and as you can see, hello world. Boom, nice. I'll ask again. All right, nice. So now you're gonna go to your favorite browser. We're gonna use a library called RustyLine for our input, because the standard input in Rust or really any kind of language is so crappy when it comes to consoles, right? For example, you don't have history. You cannot like use the up and down arrow keys to navigate your history, basically which commands you have used before and stuff. This is the first one. The second one, there's no auto completion. Third one, you cannot use right and left arrow key to go so you can edit like to navigate your input, so you can edit your text without any problem. So there's just a lot of things that really in some sense suck with standard input. That's why we're going to use RustyLine. So we're just gonna copy this example. Of course, you're just gonna go to Google, right, and just say RustyLine and search for RustyLine, and you're gonna find this library. You're gonna go to, of course, GitHub. Okay, and then you have this example here. We're gonna copy it. As you can see, we're gonna go back, and we're just gonna Control A, Control V to paste everything in place. All right, so before this can work, we gotta add this library. So I'm gonna go to my terminal. I'm gonna say cargo add RustyLine, just like that. Cargo add RustyLine, there we go. Now as you can see, if we go to our cargo.toml, RustyLine is there. Nice, lovely. Now I'm just gonna save, and I'm gonna run, and we have a problem. Just to make sure, I'm gonna run it in the terminal too. Cargo R, and as you can see, we have a problem. So there's feature Rust C attributes. So the thing is about this library is that it's dependent. So RustyLine library is dependent on another crate called IO lifetimes, and that IO lifetimes crate is using some kind of feature which is called Rust C attributes, which is not part of the stable release channel for Rust. So to be able to use this library, we gotta actually switch to nightly Rust, not stable Rust. Okay, which of course sucks again, but I mean, this is basically the best library in Rust for this use case. Hopefully that would be fixed in the future, but there you go. If this error happens, I'm gonna show you right now how we can fix it. So you're gonna go to your terminal, and you're gonna say rust up default nightly. Okay, and it's gonna do that, and you're gonna see that it's gonna switch to nightly Rust. If you still don't have nightly Rust, then you're just gonna download it and then switch up. But in my case, I already downloaded nightly because I already run such a command before, right? If you want to switch back to stable, which you surely want to do if there is no need for nightly, then you can just say rust up default and then say stable, so you can switch back to the stable channel. All right, so after that, since now we have just are using nightly right now, I can just say cargo R and wait for it, and there we go. So as you can see, it says no previous history, and then we can just input stuff up hello world, and as you can see, if I make a mistake and then I want to change hello to hey, I can easily do that, hey world. And then Codotaku is cool, right? Rust is amazing. And now if I want to run, you know, it's like a previous command, then I can just use my app arrow key to go back, and then I can just press enter, and there you go. And then when I actually use Control C, as you can see, it says Control C. And if I run the program once again, and then I use my arrow keys once again, then as you can see, it saves my history, which is just amazing. So even if the program crashed, or your program or your computer shut down because of a energy an electricity shortage or something, everything is saved, as you can see here. If there we go, history.txt. As you can see here, it's saved in our history, which is amazing, right? So yeah. And also what I'm saying about Control C is the fact that this RustyLine library allows you to handle when the user like press Control C or Control D and stuff like that. Okay, so which is quite interesting indeed. So so yeah. So right here, I'm not interested into saying to the user Control C, Control D and stuff like that. I don't care. So I'm just gonna comment these guys out. Boom. Boom. So basically, if you want to do something when the user says Control D, then you can just do it here. You can handle it here. In this case, we're just breaking out of this infinite loop right here, as you can see. And I just realized I still didn't explain everything. So here, basically, we're just importing the libraries that we need, the stuff we need from RustyLine. So RustyLine error, readline error, and then RustyLine editor results. Then fn main or function main result. This is a unit. So this can be used when no completer is required. There we go. We're creating a new editor. And here we don't need a completer. That's why we're doing this. But yeah, RL, it's mutable. So if rl.load history, we're trying to load the history file. As you can see, history.txt, you can change this to any file path you want. So if it's errors, then we say no previous history. I don't care about this. I'm just gonna skip, but I'm gonna leave it there. So if anyone wants to actually do something with it, you can easily do that. But yeah. Anyways, so here we have an infinite loop, let readline result string equal to rl.readline, and here is the prompt. The prompt is basically what shows up to tell you that the program is listening or is waiting for your input, okay? And that's basically it. Here in this case, it's just these two arrows, as you can see, which is quite nice. All right, amazing. So match readline. So if it's okay, if reading the line is okay, then it's going to give you whatever input the user have gave you. Here it just adding that input into the history, as you can see, and it's using the as str because add history entry takes in a reference to an str, not a whole string, an allocated string. And here we're just printing line, 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 and this is what we're going to change soon. Okay. And so that's pretty much it. Here, if an error happens, then we're going to see if it's a readline error interrupted, then that basically means that the user pressed Control C. If there is an error, readline error AF, that means that the user have pressed Control D. And if there's any kind of other error, then we just print line error, ERR, and stuff like that. So yeah. In this case, I'm not doing anything really. When an error happens, I'm just breaking the infinite loop so we can get out of the infinite loop, and then we can save the history without any problem. If we weren't using such a thing which can handle such errors, then what's going to happen when you say, for example, Control C, then the program will just shut down immediately, which will not allow you to even save the history, which of course sucks. So yeah. So that is nice. All right. So what's next? Here, after adding the history entry and after we got our line from the user, so as you can see, line is a string. Now, instead of print line, line, and just printing it back to the user, right now, I'm actually going ahead and I'm going to say, let result equal to execute line. That's basically what's gonna happen there. In fact, maybe I'm just gonna give it a reference to the line because there is no need to actually consume the line. So yeah, let result equal to execute line. So yeah, here we're just gonna create a new function called execute. There we go. Right, and this execute function will take an str, which is gonna be the line. So yeah, line and str, there we go, a reference to an str, there we go. So yeah, execute line str. So this should return some kind of result. In my case, for now, we're just gonna return. So basically, if you say, for example, 1, 2, 3 plus, or I mean 1, 2 plus, what's gonna happen is that it's gonna give you the result as a number, of course. So it's gonna give you 2 plus 1, it's gonna give you 3, okay? So that's basically, for now, I'm just gonna use f64, basically a float. But you can use whatever you want, really. But anyway, so basically a number. It's a float. All right, so let's start implementing this function. So for word inline dot split white space, and there we go. All right, so what's happening here basically is the fact that as you can see, every kind of token or whatever is going to be, it's going to be splitted by a space. So when we've done this, it's going to give me 1 as a string, and then 2 as a string, and then a plus as a string, and it's going to put it into this word here. Anyway, so what's going on here? Oh yeah, expected f64 for now, so it just doesn't annoy us for now. I'm just going to remove that. Okay, so for every word in line.split white space, so let's just print line words so I can show you how it looks, okay? By the way, you can actually do just this. There's no need to do that stuff. All right, print line, or you can even do this, dbj word. All right, so let's try that out. Run. Actually, I'd like to run in the terminal. It's much better. Cargo R, boom. As you can see, it gives me where I can put my input. I'm gonna say 1, 2, 3 plus plus. And as you can see, here we go. It's printing 1, 2, 3 plus plus. Look at that. Nice stuff, isn't it? So 1, 2, 3, 2, 3, 4 divided by, and there we go. So it basically splits by white space. And now we can do whatever we want with that word that we have splitted. All right, so lovely. Next up, we're gonna see what is that word. Is it a plus operator? Is it a number, or what exactly? So yeah, so let's see, match. So let's match, let's see if it's an operator like a plus, for example. So if it's a plus, then of course we're just gonna handle the plus operator, right? So yeah. Otherwise, if it's what's going on here? I don't know what they mean. Anyways, otherwise, if it's something else, then we're gonna do something else, simply. All right. Oh, match word. I forgot match word. Okay. So we're matching word. If it's a plus, we're gonna do whatever is inside of here. If there's anything other than this stuff, then we're just gonna do whatever is in here. Okay. So so to start, we need a stack, okay? We need a stack. So, and why we need a stack, let me show you. Let me show you why. So, when we have, for example, 1, 2, 3, 2, 3, or let's say 1, 2, 3 plus plus, okay? So we have this little RPN expression. So what's gonna happen here is we're gonna go through every word delimited by a space, right? White space. So the first one is 1. We're gonna try to convert it into a number. and then we're going to push it into a stack. Okay, so now I'm going to show you my stack. My stack will be, let's say this is my stack real quick. Here we go, 1. So right now 1 is in my stack as a number, as a float, for example. And then here we're going to see 2. Then we're going to push 2 into the stack. 3, we're going to push 3 into the stack. And then when we come to plus, instead of pushing plus, no, we're going to actually pop 3 and 2. We're going to pop them out. And then we're just going to basically add them together, right? And that would gives us 5. And then we're going to take that result and then we're going to push it back into the stack. And there we go. Now we got 1 and 5. So basically this whole thing got us the result 5. And then 1 is still remaining there. That's why we have the second plus. When we come to the second plus, what's going to happen? It's going to pop from the stack 2 elements, and then it's going to basically plus them together, right? Add them together. It's going to see the result, which is 6. And then it's going to push the 6 back to the stack. And of course, since we're done from the input of the user, we're just going to return the last element in the stack because that's going to be our final result. And that's basically how RPN works. So simple. All right, so yeah, pretty much that's basically it. So that's why we need a stack. And hopefully that's understandable. So let's say let stack is equal to a vector. Well, let's just say vec new like this. Of course, there's no actual stack in Rust. There's just a vector. And inside a vector, there is the method push and pop, which is basically a terminology that is used for a stack. So basically in a vector in Rust, it can be used as a stack. So yeah. So if it's not a plus, if whatever word is not a plus, then we're going to try to take that word or basically that string and turn it into a number. So how we can do that? Well, word.parse. So there's a function or a method inside string that allows you to parse it into something. So I can say just word.parse. Okay, so and then basically what I'm going to do, I'm just going to push that, because parse basically will return for me a number. Well, not exactly a number, but just, you know, as a just for explanation for now, okay? But we're going to see what's the problem soon. So stack.push word.parse, just like that. But all right, let's make this mutable, this stack mutable. There we go. So stack.push word.parse. So the thing is, this parse thing doesn't gives us you know, a number. It gives us a string, like actually a result. So that result will be like if the conversion was successful, then it's going to return OK, a result which contains an OK value. And if it's not successful, then it's going to return an error value that's containing the error message or whatever. So here for now, we can just say .nwrap, but we can handle that error later. Actually, in fact, all right, for now, let's just say nwrap. We can handle that error later. .nwrap, just like that. So now basically if it's not a plus operator, we're just going to try to convert it into a number. So and then we're going to push it into the stack. That's basically what we're doing here. There, stack.push word.parse.nwrap. Of course, there is something missing that we still have to do there, but for now let's just ignore it. All right, so for the plus, it's quite simple. We're going to say let operand 2 equal to stack.pop. And let operand 1 equal to stack.pop. Some people that are good with Rust have already noticed the problem, but we'll see later on how we can actually solve that. It's quite simple. So let operand 2, let operand 1. So why I'm saying let operand 2 first, then operand 1? Well, too simply because when you have 1, 2 plus, for example, especially when we're gonna implement minus and operators that needs the right order. You're gonna have a problem. Why? Too simply because, well, we're expecting it to give us 1 plus 2, not 2 plus 1, right? So it shouldn't actually reverse the order. So what we should do, so the first value that we're gonna pop after the plus is 2, which is the operand 2. Then we're gonna pop again and we're gonna get the operand 1. So that's why I'm doing it in this order. That's basically how it is. And stack.pop, for now, I'm just gonna say the unwrap. So basically what I'm saying, when I say unwrap, I'm saying that if there is an error or you cannot find a value in terms of options and stuff, then basically just crash the program. That's pretty much it. We're not going to handle the errors for now, just for the sake of simplicity, maybe later. Of course, not stack.unwrap, stack.pop the unwrap, just like before. And there we go. Now we got operand 2 and operand 1, which are supposed to be numbers, hopefully. And then we're just going to push the result. So let result is equal to, first of all, operand 1 plus operand 2, because that's what this operation or operator plus does, right? And so after we got, by the way, I don't need this. After we got our result, we can push it into the stack. So stack.push result. And there we go. Now let's try to run this program and we're gonna see the problem. Run, and there we go. Type annotations needed. Operand 2. So basically what it's saying here is that consider giving operand 2 an explicit type. It basically doesn't know the type of whatever is in the stack. Why? Too simply, when we said word.parse, we didn't tell it exactly, like you have a string, which type exactly you want to parse to. Do you want to parse the string into a float? Do you want to parse it into an integer? Do you want to parse it into I don't know what? So that's why. So there is a lot of ways to do this, okay? We can, for example, go to the stack and then just annotate it with the type. We can say it's a vector of type f64, for example. And that's gonna work, okay? As you can see right now, it actually inferred the type for me. And this is gonna work, right? If we run this, as you can see, it does work. Let me run it in the terminal. Cargo R, boom, 1, 2 plus. There we go. As you can see, it runs without any problems, but we're not doing anything with the result. And in fact, we're not returning the result at all from execute. Why? Well, too simply, yeah, we're creating a stack, then we're processing everything. Either we're pushing or popping into the stack, as you can see here and there. But then when we're done, we just don't do anything. But we should return the last value in the stack, which is going to be the result, basically. So we're going to say stack.pop. For now, we're just going to say .unwrap. So if there is any value in the stack that is left to pop, then we're just going to crash the program for now. And of course, we have an error. Why? Because the return type of the function should be an f64, because the stack is a vector of f64s. All right, so if we run this, all right, so 1, 2 plus, and still nothing happens. Why? Too simply, if we come here, yes, we're getting the result from the function, but we're not printing anything. We're not doing anything with that result. That's why I'm going to say print line, and I'm just going to print the result. There we go. Let's run right now. I hate that terminal. Cargo R. And then I can say 1, 2 plus. There we go. It gives me 3. And there you go. You got the basic RPN calculator done. If you say 1, 2, 3 plus, boom, it tells you 5. But look at this. It tells you 5, not 6. Why? Too simply because we have only one plus operator, and every operator only consumes two operands. Okay, so what happened here is that 2, 3 plus, it gives us 5. And now in the stack, there's two values. There's 1 and 5. where 5 is the last one. That's why we got the last value, which is 5. So yeah, but if you want to consume 3 operands using the plus operator, then we're gonna do plus 2 times, and there you go, 6. So that is lovely. All right, now by the way, if you do, for example, plus, then it's just gonna unwrap. It's just gonna crash the program basically, because we're not handling those errors. We're just saying if anything happens unexpectedly, just crash the program, just to keep things simple for now. Maybe later on we're gonna actually fix. So I said about the fact that there's a lot of ways to do this, right? So you can either annotate the stack as a vector of f64, or you can say, for example, operand 2, let's say it is of f64, and this also gonna work. I mean, if I run this, yep, as you can see, it compiled. As long as there is a way for the Rust compiler to infer, to know the type of whatever is in the stack, then it's just gonna apply it to the others. You only have to tell the Rust compiler the type of whatever you want once, and then whenever you use it somewhere else, it's just gonna know basically. So for example, I can add f64 here, I can add it here, I can add it just here, etc, etc. Or which I'd rather do is come to the parse function, and then I can use the I'm not sure what it's called actually. I guess it's called fish syntax or something like that. I don't really remember. But basically you do something like this, and then here you tell it what type you want. In this case, let's say f64. Now if we run again, and there we go. As you can see, it works. 1 plus. I don't like to use this this debugger of the CLine IDE, because as you can see, for some reason it doesn't include the prompt. As you can see, it doesn't include it for some reason. I don't know why. But anyway, and it also doesn't really support Control-C, Control-D, and all the beautiful stuff properly. But anyway, for the terminal, it does. That's why I like to use the terminal. Anyway, so as you can see, that's what we got there. Now, the thing is, what I would like to do next is to talk about something, which is that f64. So this is hard-coded, right? f64 is hard-coded. Let's say the user doesn't want to use floats in his operation. Let's say he wants to make or to calculate some operation that is, you know, really precise, okay, and just using integers. So that means that a float is a really bad idea for precision, because if you don't know, a float loses a lot of precision when you do operations with time. Okay, so more operations means more loss of information, less precision or more imprecision. But anyways, so how we can generalize this? We can use generics, right? We can use generics. So how we can make this generic so it works with any kind of type? Well, let's see. So if we say execute here, and then we can add these guys here, this I don't know what they're called, right angles or right brackets, I don't know. But anyway, so here you can add whatever type you want. I'm gonna call it T. You can call it whatever you want, but this is kind of like the convention. We use T, V, U, blah 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 blah. Anyways, so here after I declared some kind of type, whatever it is, then I can use this. So instead of f64, I'm just gonna replace it with T. There we go. And by the way, never try to use a generic from the start, because it's just not gonna work for you. As you're gonna notice here, there's gonna be a lot of errors that we have to fix. If you're not advanced, at first, just use any kind of type that you see fit. And then later on, you can generalize your function, just like we do in math. We start by solving, you know, like a sample problem, then we try to generalize it into a formula, etc. This is basically kind of like the generics right here. So yeah, as you can see, all the F64s, I replaced them with T. Well, you might think that I can right now just run, but well, Rust have some plans for us. Okay, so what we have in this error, as you can see, the trait bound T from str is not satisfied. And we also, so it's right here, stack.push here. The trait bound T from str is not satisfied. So why in this line exactly? So here we're trying to word.parse. So we're trying to convert a string into a certain type that we don't know, which is T, okay? And if we want to do that, we have to tell Rust that that type, we should limit that type to any type that can actually be able to be converted from a string to whatever T it is, right? So that's why Rust tells us that we need this trait bound called from str. This is basically us going ahead and declaring to Rust that we want to limit this generic type to some types that inherit certain behavior, okay? In Rust, these kind of behaviors or interfaces are called trait bounds, or they're called traits, basically. But yeah, anyway. Now, as you can see, Rust already gave me the solution, which is really cool. So we can just go ahead and add it. Let's see also other stuff before adding this. There's here, cannot add T to T. So here, basically, if we say just T, it means any type in the whole universe. But not all types in the universe can be converted into a number or whatever, like can be converted from a string, right? And not all the types in the universe can be added together, right? You cannot add a cow to a cow, I guess. I don't know, but yeah, I guess so. So that's why you gotta actually also declare to Rust that this type, this generic type, should be limited to certain types in the universe or whatever that can be added together, or that at least supports the operation add, that can be added, not necessarily added together. And that's why what we're gonna see later on. But and now let's see what we have here, result. And also there's another error called type annotations needed here. So what Rust is saying here is the fact that it doesn't know what results will be, what type it would be. And I know how to fix that error, but for now, let's just go back to the first error. So in Rust, usually you would like to start from the first error, which is because sometimes the first error, if you fix the first error, some errors, some other errors can be fixed that comes later on, okay? So always try to start from the first error. So the first error, Rust already tells us the solution, so I can just copy this. As you can see, I'm just gonna add, this is called a trait bound. So basically here we're limiting T to whatever type, generic type that inherits from str. Okay, now let's run again. Now we have another kind of error, which is crazy. Okay, let's see what's going on here. All right, doesn't implement. So T as from str error doesn't implement debug. Huh. Okay, where? Which one? Here. Okay, let's see what's happening here. Required by bound introduced by this call. So for in something in this call cannot be formatted using because it doesn't implement debug. Huh? What? The trait debug is not implemented for T required by bound in result TE in wrap. Oh, why in wrap needs that? Interesting. Required by this bound result TE in wrap, further restricting associate type where T from str error debug. Well, basically it's saying that this inwrap function is trying to, let's say, print an error, basically. Interesting. So the easy solution here for now, let's just add this guy, okay? Copy T, where T, and we can just add it here. So basically here, we're saying where T as from str error debug. So basically the error of T should be able to be debugged. So basically should be able to be printed. So yeah, so when inwrap happens, it can actually go ahead and print the error that happened to the user. But anyway, you can just ignore this for now. We're gonna look for another solution later on. But anyways, let's run again. Let's see what we have. Use of indeclared type from str. Yep, because I gotta say this, because from str is not in the scope. And there we go. The same thing can be said about this. I gotta say use std-fmt debug. Run again. All right, fine. Now we're pretty much kind of done with the first error. Now the second error, cannot add t to t, which is interesting because we gotta just add this guy here. All right, so we're gonna add another trait bound, std ops. Basically, ops is operations add. Basically, here we're saying that t should be able to be converted from a string and also should be able to be added. Okay, and so let's run again. Of course, we're gonna get another error that comes from the error that we have just solved, which is. Basically, it says type mismatch resolving t add blah 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 output equal t. So here, basically, what it's saying that it doesn't know what type will be the result of adding t to t, because here we just said that it can be added, but there is some things that if added together it can give you some certain type that is like a different type than the added values. That's why you gotta actually make sure to tell Rust that the output is equal to t. So basically you're telling to Rust that limit this generic to whatever value that can be added together, and that would give me back the output, that would give me back the same type, okay? So that's pretty much it. And as you can see here, it did actually tell me that output equal to t. All right, so let's try this out once again. Boom. Now that error have gone away. Now we got the last error, which is right here. Let result equal to execute line. All right, so let result here. Basically, what Rust is telling me that it doesn't know what kind of type result will have, and that's because I didn't give the generic t, I didn't give it any kind of concrete type, because when yeah, you can actually go ahead and make generic functions, but when it's the time to use them, to call them, then you actually have to specify the type, the generic type. And that's why I'm gonna go ahead here and I'm gonna specify the generic type. Let's try f64. Although we're gonna use this fish syntax, as you can see, just add two columns before the parentheses for the call. Just add these two guys and this and this, and then here you just say what type you want to assign to t. Okay, so basically what's gonna happen there is that it's gonna replace that f64, that basically t with that f64 that we gave it inside of here. Okay, but it's gonna make sure, because Rust helps us a lot in terms of safety, it's gonna make sure that whatever type we gave it here, for example here f64, can it be converted from string? F64 can be able to. So that's good. Now let's see the other bound. std ops add output equal to t. When you add a float f64 to an f64, it gives you an f64. First of all, it supports add, the add operation, and then the add operation gives you back the same type, which is f64. So that means that all of the bounds were actually, there's also another bound, which is here, where t as blah 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 this crazy stuff here. So it's gonna check all of these bounds. If they're good to go, then it's gonna accept. Otherwise, it's gonna actually not allow you to compile the program, which is interesting. So yeah, now let's try to run this up. I want to use the terminal. Okay, cargo R, let's say minus 10, 10 plus, and as you can see, 0. So that is beautiful, 0. All right, so now let's try some other type than f60. Actually, by the way, you can say 3.14, let's say, and then 6.24, I don't know, plus. As you can see, it works. It also supports the comma. And why it supports the comma? Because we're using f64. But now if we use something like, let's say i64, i64 also respects those bounds, those trait bounds of the generic. Now if we run this, for i64, if we say 3.14, I don't know, plus, it's not gonna work. It's gonna crash the program. Why? Too simply because, as you can see, we have a parse int error, invalid digit. So what happened here is that we have tried to convert 3.14 into an integer, which of course is not possible, right? So it crashed the program because we haven't like handled the error. We have just said to nwrap to crash the program. And so yeah, so basically if you use, for example, i64, then you can only use integers, 3, 4 plus. While this is a bit limited than f64, but it's much more precise in terms of calculation. So it really depends on the use case. And basically what you can do right here is that we can let the user, right? We can let the user specify what type he wants to use, right? Is he wants to use integers or he wants to use floats? All right, so let's think about some kind of syntax. So for example, you can say the user should say i64, let's say, and maybe this, I don't know, let's say basically int 3, 4 plus. Okay, if he wants to use float, then you can just say float 3, 4 plus. We can do this easily because right now, like basically if we didn't use the generic, we didn't make the function generic, then we have to actually copy this whole function and create it with another type. You know, which is crazy, but since we're using the generic, this is easy. This is really easy. So here's how to do it. First of all, we gotta check the first, we gotta split and check the first, what it's called. All right, the first word, okay, the first token or whatever you want to call it. Anyways, so here I'm just gonna say let type is equal to, well, we'll just call it t, I don't know, ty, okay, or typ, because type looks like it's part of Rust syntax. That's why we cannot use it as an identifier. So let type is equal to, let's see, let type. All right, so we're gonna say line dot split, but I'm gonna split n. What n means that I want to split n times. So So if I have, let's say, 3 spaces and then I split only 1 space, then well, you're gonna get just the first word, and the other stuff will just, you'll just get it as a whole. And that's what I'm gonna do here. So split in, maybe, we'll see how it goes, because I never really tried this which is crazy, but yeah. All right, so line.split in, I'm gonna split once. In fact, there is probably another function called split once. There we go, split once. And the limiter is, well, actually, let's use this guy, okay? So yeah. All right, now we're gonna see dot, we're just gonna say dot in wrap or. So in wrap or, so this is gonna give us an option. So if it was successful, it's gonna give us a sum, and it's gonna give us the first part and the second part, as you can see. But if that character, that delimiter, doesn't even exist, then it's gonna say none. And in that case, if there is none, if the user didn't give me any kind of type, then I'm just gonna assign it some type from let's say I'm gonna assign it float, okay? Dot f dot float, basically. So that is nice. Or maybe I can say f64. Let's just go with f64 for now. I don't know really. Let's go with flow. All right, so in wrap or. Now at this point we have a tuple, I believe. Let's see. As you can see, yeah, we have a tuple of 2 strs. Okay, so the first str will basically have the type, and the second one will contain the actual line that we want to, like the actual command or expression. Let's call it an expression. Okay, that's much better. All right. So in Rust, it's not like Python. You have to actually tell it that it's a. And basically here I'm unpacking the tuple into 2 values. And here, instead of giving it a line, I'm going to give it expression. An expression is already an str, reference to an str, so I don't have to add that reference thing. And since we're here, I would like to actually not say line, but let's say expression. Let's call it expression. That's much better. So line expression. It's not much better in performance. It's just that you know, it's much more descriptive in code, right? So yeah, pretty much. Now we can even go ahead and print line. Just as a start, let's print line type. And of course, since we're in Rust, we gotta do this. Gotta do it this way. And let's see what's gonna happen. All right, mismatched types. Oh my God, what's going on here? What do you mean? Let's split once expected tuple. Oh, gotcha. Gotcha. Oh my God. All right. So here I actually gotta give it a tuple. And by the way, since this is getting a bit crazy, I'm just gonna go to the next line. All right. So the unwrap, and here I'm actually gonna give it a tuple. And then, so the first tuple gonna be a type float. The second one though, I'm just gonna give it back line, hopefully, if that's possible. Mismatched type, expected str. All right, so I'm just gonna say this, right? So reference to line. So basically here I'm saying that if the user didn't give me a type, what I'm gonna do, I'm just gonna say that the type is a float and the actual expression is just the line itself. That's pretty much it. So yeah, let's try right now. A run, there we go. And now I can say 1, 2 plus, for example, or whatever. And as you can see, it does tell me the type. In this case, it's a float. If I say, let's say integer 1, 2 plus, but of course I gotta use this guy right here, just like this. As you can see, it really goes ahead int, and it did evaluate this expression correctly, which is really interesting. And in fact, I would like to call this evaluate instead of execute. Yeah, that would be better. But I want to tell you another problem here. Because if I say integer, right, and then I added an extra space, 2 plus. Oh, it actually worked. All right. Oh yeah, I know why it worked. I believe. Yeah. Because I'm using split white space, and split white space also get rid of extra white spaces in the middle or the back or the front or whatever, which is really beautiful, which is really amazing. That's basically what we want. So first of all, let's just call this evaluate, which is much better in my opinion. Alrighty. So evaluate, that's much more descriptive. Lovely. So, all right. Now the thing is, we're still not doing anything with the type. So let's get started. So we're gonna match on the type. We're gonna see if it's a float. If it's a float, then we gotta do what should be done with floats. Okay, so let's just copy these guys, I guess. Hold on, how can I do it? Yeah, I'm just gonna do it this way anyway. Right, float, let result. And in this case, I gotta use F64 or whatever. Okay, as you can see. So if it's a float, that's what I'm gonna do. If the user have gave me another thing like an integer, int basically, then I'm just gonna say, instead of F64, this time I'm gonna say I64. And this is where the power of generics comes in, which is really beautiful. Right, so after matching though, it's gonna do a semicolon, I guess. Match must be exhaustive. All right, interesting. So if the user gave me something else, I'm just gonna tell him that I don't know this type. It's not it's unimplemented or something. All right, let's see. Implement line. Let's see. Let's tell him an implemented type, I guess. Implemented type, and then I'm gonna give him the type. And the type is gonna be TYP. There we go, semicolon, and let's try it out. All right, so if I say float, right? Then I say 3.14, 3.5, whatever, plus. As you can see, it works. And this is where the imprecision of floats, as you can see, this added 1 for no reason. The actual precise results is just 6.64, I believe. 14 plus 50. Which is yeah, 64, but then you have this imprecision of 0 1 0 0 0 0 0 1. But if we use integer, right, yeah, if we use integer and then we try to say 3.14, then well, it crashed the program. You see how that goes? And because too simply integer is not supposed to have to run floats. But if you run the same code, okay, let me actually run that in the terminal. Right, cargo R. As you can see, I can go back in history. If you do the same thing with a float, you get the actual result. If I say int 3, 4 plus, whatever. So that is quite amazing. Anyways, so that is lovely. And you can add whatever types you would like and all sorts of crazy stuff. So that is amazing. Let me actually format the code real quick. Reformat RustyFMT. In your terminal, you can just say cargo fmt and it will do the job for you. So yeah, pretty much. So this is quite amazing, lovely. Now I guess let's add some more operations, right? Yeah, let's do that. Let's do that. Before adding extra operations, I would like to do something really cool, which is to tell the user exactly what operations I'm doing, which is going to be really amazing. So let's print line. This is plus this equal to this. So equal to result, and this is operand 2, and this is operand 1. That's basically, and of course the semicolon right there. And there we go. Now let's notice something. Oh, crazy stuff. Plus stdfmt display. All right. Well, to use these t values inside of here, you gotta actually also limit them to stdfmt display, which is interesting. Oh man. All right. So stdfmt debug and plus. Can I say t? Can I say it this way? Oh, remove this plus here. Can I say it this way? Let's see. I also gotta add the copy. Oh my god. Why add a copy? Move occurs because operand 1 has type t, which does not implement the copy trait. The thing is, oh yeah, copy. Interesting. It's also something else that I would not like to explain right now. But basically, from all this crazy stuff, we can do something really interesting, which is the fact that in our evaluate function, we're interested into the generic t. We're interested into numbers, not numbers, but numerical values, floats, integers, whatever numeric value. Instead of doing all this crazy bounds that describes a numeric value, right? We're gonna add later on stdops, multiplies, divide, etc., which is gonna be crazy. Instead of doing this crazy stuff, right? We're gonna go to a crate called num traits. So we're gonna actually import this num traits crate. All right, so terminal cargo add num traits, and notice here it's not a underscore, it's this guy right here. So enter, boom, there we go. We have added it, as you can see, to our cargo.toml. After you add it, then we gotta say use num traits. Okay, and then here, instead of doing this craziness right here, we're gonna delete all of this stuff. No need for all this stuff, I believe. And let's try this up. Num traits. Right. I don't really remember. Is it this or this? Yeah, this. And then you just say num. That's it. So here, basically, we're limiting this t, generic t, to any kind of numeric value. And this numeric value is basically, as you can see, the base trait for numeric types, covering 0 and 1 values, comparisons, basic numeric operations, and strict conversion, which is quite interesting. All right, so this num traits crate gives us something called num, which is a trait that basically covers all kind of traits that is exhibited by numeric values like f64, whatever. Which is quite interesting. So if we run this, and still we need this kind of thing right here, looks like. So let's add it. Although we can, instead of doing it here, which makes it look really bad, I'm just gonna say where t is this, where t is num traits num and std str from that. Well, looks like somehow we also need this, but yeah, sure, fine. Copy, boom. Actually, not this, right? Use vindicator. Oh, std str from str, and here debug, which is kind of qualified path to stdfmt debug. There we go. Run. We also need display. Oh my god. We still need all this craziness. Let's just do it in another place. There we go. And let's add this because it's become so big. Huh? Oh. All right, let's do this, this, maybe. T, actually, let's do T. There we go, T as that. All right, there we go. So yeah, let's see if I can actually make this better. Reformat file with rustfmt. There we go. All right, so let's see if this works. We also need copy. Although I found it really weird because num is supposed to have the copy trait and stuff like that. But interestingly enough, it doesn't. Which is crazy, but fine. T copy. And just to make it cleaner, I guess we'll just do T again. This. All right. All right. Comma here. Oh man, what's going on here? No idea what's going on. Must have a, oh. Is that the case? No. Oh, right. Oh, gotcha. Interesting. So what about now? Finally, oh my god, that took years. Terminal. But right now, since we added num, we don't have to add the traits like add, multiply, divide, which we're gonna need all of that later on here. And we also get some extra stuff, like we get 0, we get 1 values, we get comparisons, we get all sorts of craziness, right? Why we need that or what is that? Well, I'm gonna show you in a bit, I believe. So anyway, let's try this out. Cargo R. Let's just make sure everything is still working just fine. Oh, right, there we go. And we don't need to print this right now. Or actually, we do. Yeah. All right, so here we go. So 1, 2 plus, as you can see, it tells you exactly what operations happens. 1 plus 2 equals 3. We say 1, 2, 3, 4, 5, plus, and there we go. As you can see, 4 plus 5 is 9. 3 plus 9, as you can see, is 12. 2 plus 12 equals 14. 1 plus 14 equals 15. And as you can see, the output is 15. As you can see, it tells you all the operators or operations that happens, which is beautiful. If you don't want that, then you can basically just comment this out. Pretty simple. We can add other operations, but before adding other operations, I want to think about how I'm going to handle errors. So we have two things that we want to handle errors in here. There's basically two things. What we want to happen when we don't find operand 2. For example, if we say something like this, what we want to happen. And for operand 1 here, it's basically what we want to happen if something like this happens. Something like this happens. Hold on, no. Actually, no. For the first one, it's gonna error if you do something like this. So basically, you just give the operator without any operands. The second error would happen if you gave one operand. That's basically it. All right, let's think about it. How can I handle it? All right, let's see. So if I say something, I guess we just got an error anyways. Yeah, probably. So instead of actually returning t, I guess I'm just gonna return a result t. I I got another error that I'm gonna show you. But result t, comma, here the type of the error. The type of the error will be just a string that describes what happened wrong, I believe. Maybe. Well, maybe we can do better. I don't know. Let's keep it simple for now. Let's keep it simple. The error will be just a string. I don't care. So yeah, result t, comma, string. Right. Now we have a problem. Wrong number of types arguments, expected 1, found 2. And this is an error that's kind of nasty because basically here RustyLine example actually goes ahead and overwrites the default result, which just sucks, okay? But we can easily fix that. I'm just gonna remove that from the import or the use statement, and then I should make sure to do it here. Okay, hold on, Control C. Yeah, all right, so RustyLine result. Okay, so RustyLine result. There. And now it got fixed. All right, lovely. Alrighty, so by the way, what is copy? It's basically when you pass a value to, let's say, a function or somewhere another scope or whatever, let's not go into details. What happens is, instead of giving a reference to that function or whatever, or consuming that value, you're basically gonna pass a copy of that value. All right, so hopefully that helps, but you can check out the documentation of Rust or something because it's kind of complicated to explain. Anyway, what we were doing? Oh yeah, we want to handle errors, right? Oh yeah, lovely. So .inwrap. Now instead of saying .inwrap, I'm just gonna say, let's see. So I'm gonna map error. Okay. Can't we do that? Well, not, it's an option, so we're gonna map. Oh, can we say, how do I do that? Expect insert and then as mutable. I actually, can I, like, how do you actually go from an option to a result? Is some, no. Right, from option to a result. Rust, option to a result. I don't really remember. All right, the OK or for some reason, somehow. Option has the OK, so for exactly this, well, for option T to result T, blah, blah, blah. Stop recording. Okay, let's see, the OK or. Okay, or what? Oh, here I can give it the error. Nice. So if it's none, then we're gonna error and we're gonna say operand 2 need, like here we basically need 2 operands are required. 2 operands are required before plus. There we go. Or I can just say before word to generalize it even more. So before word. So I guess, oh yeah, I need to use the format function for that. Format function. There we go. And I believe that's it. Yeah, I believe that's it. So I'm gonna, the same thing, hold on a second, hold on. I'm gonna Rust FMT, there we go. This is much better looking. Now I'm just gonna copy this guy, come here, do this. There we go. Dot. Oh, I don't need dot pop here. Okay, stack dot pop. Or here I'm gonna say 1 operands are required before a word, or forward. Okay, are needed. Actually, instead of required, maybe I should say needed. One operand is needed. One operand is needed. There we go. Let's try that out. But before that, after okay or, I'm just gonna add that because this gives us a result. But I'm gonna propagate the error. If an error happens, I'm gonna propagate it back into the function. And I'm gonna use this guy right here for that. And hopefully that would work. Not sure though. And one. We'll see how it's gonna how it's gonna work. Let's see. So, right. Evaluate f64 expression. So it's either gonna be result f64 string or whatever. So here I can just say match result and see if it's a string. If it's a string, then we're just gonna print that string. Otherwise, we're just gonna print. All right. So match result. If it's okay, then that means we got a result. And that means we're just gonna print line result. Otherwise, if it's an error, then we basically get an error message. And of course, we're just gonna print line that error message. There we go. There we go. Now the same thing goes on here, basically. And instead of f64, we're gonna say i64. All right, and print hopefully. And oh yeah, here we need this guy and this guy. There we go. I'm gonna copy the same thing and copy it back here. You ideally want to make this into a function probably, but for now let's just keep it simple. Okay, oh yeah, in stack.pop here you gotta add okay, because right now we're not returning just a value. Okay, we're returning a result that can contain a value. So here we're just saying that everything went okay, and then we're just giving it the result. And oh, we gotta actually deal with those two in wraps, but for now let's just go ahead and see what's gonna happen. So if I say 1 plus, as you can see, it says 1 operand is needed before plus. If I add that operand, boom, done. If I just say plus, it's gonna say 2 operands are needed before plus. And there you go. There you go. You can even make this in red or something later on using some kind of library. But yeah, I'm pretty much not the best in terms of Rust, right? In coding Rust, but this is what I got for now. If there's anyone who have some suggestions or whatever, let me know in the comment section. Right. So, what's next? I guess. Stack.push result. Stack.push result. I think we're done here, right? Okay, or can we create some kind of closure that would basically gives us the 2 operands, so we don't have to do all this crazy stuff for every operator? Yeah, that would be interesting. All right, let's try that out, I believe. let's try that out. So how to do that? Okay, let's try. Let, I don't know, what could I say? What could I say? Let's just call it OP for now. I don't know what to call it. And here, it's basically gonna do, it's gonna do this stuff. I'm not sure if this is gonna work out, but we'll see. So let's operand 2. All right, and then after that, we're just gonna return operand 1 and then operand 2 inside a tuple. Does that work? No idea. Let's run this. Although we need the word here, well, let's just run this and see what's gonna. There we go. I need the word here. We run this up. Cannot use the in a closure that returns that. Oh yeah. Interesting. All right, so can I say just okay here? That may work. Consider giving this closure parameter an explicit type. I don't need to, I guess. So let's try it out. Let's try it out. All right, so I'm just gonna say let operand 1 or operand 2, comma operand. In fact, I'm just gonna go ahead and say operand 1, operand 2. Oh yeah, I'm already doing it actually. So let's operand 1, operand 2 equal to. I just called that function for now OP. I don't know what to call it. And then here we're just gonna pass in the word. Of course, this is a tuple, so we can impact that tuple into 2 variables. And let's see if that works. All right, so we have a problem, mismatched types. What? Okay. Oh, okay. I can just do this maybe. Does that work? Maybe, I don't know. Consider specifying the generic arguments. Where? Here. Operand 1, operand 2. What they are. Oh, interesting. Operand 1, operand 2. Operand 1 and operand 2 will be T, I believe. Does that make sense? Yeah, it does make sense. Let's do it here. Why not? I don't know. All right. What's going on here, bruh? Cannot infer type of the parameter type TE declared on anomalous result. Oh, interesting. Interesting. So, all right. All right. So instead of doing this crazy stuff, all right, I'm just gonna say fn str. Not sure if it's done like this or not. Anyway, result t comma string. Does that make sense? By any chance? Run. Expected type parameter t found tuple. Oh, what? Oh yeah. T comma t. What about now? Stack captured here. Oh my god. Oh my god. Can I just do this somehow? No? Probably not. Not really. Well, I cannot capture the stack then. This is crazy. This is crazy. Stack word. Expected if in pointer found closure. Stack captured. Alright, interesting. So it basically captures our stack and, well, stack.pop. Well, that sucks. Oh my god. Let mutable stack. And we do need the stack to push stuff up. Well, you know what? Let's go back. This is going crazy. Let's just go back. I was looking for it. All right, fine. Right, we're back into a working state. 1, 2 plus, boom. All right, so just for now, just copy paste. That's why I just copy paste, just so I can go through those crazy errors. Okay, so plus here it says just minus. And yeah, I know there could be, an closure, but as you've seen, a lot of things happens wrong. But anyways, so just gonna make sure to add both of them. Oh, and in fact, to generalize it even more, I can, instead of minus here, I can just say word. Yeah, so I don't have to change it here. I only have to change it here. So yeah, let's just generalize that. So copy pasting becomes even easier. Let's see if minus works right now. So 3, 2, minus. As you can see, 3 minus 2 equal to 1. Boom. Lovely. If we weren't to do operand 2, then operand 1, then what's going to happen here is that it's going to say 2 minus 3, and it's going to do that. it's going to be wrong. So yeah, that's lovely. All right, after this, we can add the other operators without any problem. There we go, paste, copy and paste, multiply. There you go, just change it here again. There you go. Boom. All right, okay. Again, instead of multiply, you can say divided by. All right, and all right, and we can add even the modulo operator, because why not? And there you go, the modulo operator. We can even add some constants. How you can add constants? Well, we're just gonna say, for example, pi. Pi is basically, we're gonna say stack.push 3.14. Although we're gonna have a problem here, maybe. Yeah, probably. Which not gonna allow us to add constants, I believe. Because we have in generics, maybe. Does that make sense? Expected floating point found type parameter t. What do you mean? Alright, push. Actually, let's remove this for now. Interesting. Alright. Can I just comment this out for now? For the moment. See if it's the problem. Yeah, it is the problem. And as you can see here, 2 times multiply. There you go. 2, 3 times plus. Look at that. 2 times 3, as you can see, 6. And 2 plus 6 is equal 8. 2 plus 6. Which equals 8, right? Yeah, so probably cannot do constants. Because we don't know, we have a generic t, right? So we don't know what could happen wrong. So like, for example, if you have an integer, if we're working with integer, then pi doesn't work out, right? I can't happen to have 3.14. Although, I'm not sure. I'm gonna try some stuff, though. I'm gonna try some stuff, if it's possible. I don't think it was gonna work, but let's just try. An as expression can only be used to convert between primitive types to words. All right. So I cannot use this. All right. Can I say try into by any chance? And of course, the unwrap for now. Run. From float. It's not implemented for t. We're gonna add some more crazy stuff. Let's try anyways, just if someone wants to do that. All right, so where's the error? Okay, so what should I add? Required for float to implement into T. Required for T to implement try from float. Okay. Let's copy this and let's see what's gonna happen here. T is this. Can I say, I guess from try from F64? Would that work? Consider further restriction to associate type. T as try from error debug blah 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 blah. Well, let's try it, I guess. Right. Consider importing one of these items instead. Not a trait. Oh, never mind. Let's qualify path to std fmt debug. The trait from F64 is not implemented for I64. Oh my god. All right, so as you can see, it's just not gonna work out well. Yeah. It's just not gonna work out well because of Rust's safety. So yeah. Let's just remove this stuff anyways for now. Let's just remove this stuff. There might be a solution, I just don't know how. So yeah, let's run. And let's say 1020 plus. It would have been, of course, it would have been possible, like if I actually made an evaluate function for each type, for each concrete type. But that is not something that is scalable. Anyway, as you can see right now, it works. And I can even say something like, I don't know, 9 to modulo 1 because it's an odd number, 8 to modulo 0. There we go. We can add also the pow operator, the power operator. And then maybe we're gonna end this. The power operator, we're gonna use this guy. All right, actually I'm just gonna copy this stuff up. Boom, boom. And here, instead of this, we're just gonna change it to the power operator. I don't remember. Oh yeah, dot pow. It goes on like this. Dot pow, and I probably need to add maybe another kind of let's see, type must be known at this point. Isn't it not known? No? All right, consider giving operand to an explicit type. Interesting. So it looks like it cannot do this. All right, interesting. Let's see what we have in T though. Power. No, we don't. All right, so if we want to actually handle this, we gotta do it manually. I don't know what kind of other solution we can do. It's like just use a loop and then just, you know, keep on multiplying stuff up until you get the right solution. Well, just for the sake of exercise, we're gonna do it, I suppose. We're gonna do it. Yeah, sure, let's just go. I guess let's do it. And it's not gonna be, you know, performance, it's not gonna be optimized, it's not gonna be a lot of things, right? But we're just gonna try it. Just to show you some other aspects of generics and crazy rusty stuff. So yeah, that I learned the really hard way, and that of course I'm still learning a lot. I'm still a beginner. So, but anyways, so for result here, I'm just gonna say T. I'm gonna say 1. You know why T1? Because well, I cannot say this. I cannot say this or this because I don't know the generic which type it is. So I'm just gonna use T1. So whatever. So like if you have I64, then I'm just going to take the 1 of I64. That's basically what it is. You also have T0, which you can use it's gonna do the same thing but for the 0. So yeah, let's see if there's any other stuff. Oh, there is try into here. Oh, interesting. I don't know. 2vec. It's crazy stuff right here. But these are the really most important ones. 1 and 0. I don't know about the other. But yeah. So result is T1. Now I'm gonna create, I believe, a for loop. Oh my god, we're gonna we're gonna run into another problem, right? I don't think we can do this. Yeah. Yeah, pretty much. Yep. No, cannot. Really. Because operand 1 is also a T. If operand 1 if it was an integer, then yeah, we can do this. But in this case, no, I don't think. So basically what I was once trying to do is basically for I in 0, right? And then basically say operand 2, you know, and just to say this, and then why it's saying I32 here? It's kind of crazy. Weird stuff. Anyway, right, for I in 0 operand 2, but I don't think I can do it. Yeah, because it's not an I32, yeah, no? So yeah, that's basically it. It's just not gonna work. So if operand 1 or operand 2, I mean, was an integer, then we can do this, and then we can say basically result times equal to operand 1, etc., right? But yeah, it just doesn't work out that way. So, well, we cannot really implement this right now. At least, I don't know how. So yeah. That's pretty much it for now. Is there any other NWraps that we can try to handle maybe? All right, let's see. Stack.push, rur.parse.nwrap. Okay, so here we can actually error and say that whatever that is, it's not a number. It cannot be interpreted as a number. So instead of .nwrap. All right, so dot map error. We're gonna map the error to here. It's gonna basically give me the error, but I don't care about the error. Or maybe let me try something. Map error and then just say a string. Okay, let's say a string. I'm gonna call. Okay, let's see. I'm gonna use format, and then I'm gonna say that basically I'm gonna give it word is not a number. I wonder if I can like get a generic and get basically its kind of name, but yeah, anyways. And so word is not a number or cannot be inter or parsed. Let's say word cannot be parsed into a number, I guess. So yeah, there we go. I believe that should work out. That's the other error. Let's see if we have any other errors that we can. Okay, stack.pop.interrupt. So there is no result left. And basically this will happen. I believe it will only happen when... Okay, what's going on here? Hold on a second. The trait if and once. What the? Expected and if... Oh yeah, there we go. So looks like I gotta actually make sure to do this as a closure. And I don't care about the error that we got. Run. No implementation for result. Oh. Oh, I think I got what they're talking about. Because here, after map error, I gotta actually say this. All right, so it actually propagate the result. Like if there's an error, it propagates it back. If it's an okay value, then it just unwrap it and push it. There you go. Now I can say 1, 2 plus, boom. As you can see, it works. Cannot be parsed. So if I say hello, 2 plus, hello cannot be parsed into a number. There you go. So it works. All right, interesting. What's next? Okay, so this one. So this will happen if you actually didn't give any input at all. So as you can see, it just crashed on me. Yeah, as you can see, it crashed here because I gave it no input. All right, interesting. Startup pop and wrap. In that case, well, all right. In that case, I guess we're just gonna say 0 in wrap or 0. Anyway, maybe run. Oh yeah, I cannot say 0, right? I have to say T0 like this. All right, there we go. Now if I say 10, as you can see, it gives me 10, 20, but if I say plus, 2 operands are needed before plus. If I say 10, 20 plus, boom, 10 plus 20 equal 30, boom. If I just give it an empty line, which means it's not going to find anything to pop from the stack, it's just going to say to me 0, which is interesting. Although I would like to just, I mean, if the user didn't give any input, I just like to maybe ignore it basically, instead of just keep on printing 0. So that's what I'm going to do, I believe here. So if line is empty, dot is empty, then basically just continue, hopefully. Yeah. Oh, I'm not in Python here. Oh my God. There we go, continue. Is that how it works? I think so. As you can see right now, as you can see, it works. So when I just give it an empty line, it just ignores me, basically. Let me show you more in the terminal. As you can see, when I say enter, it just ignores me. 1020 plus, boom. Lovely. Alrighty, interesting stuff. Okay. We have done a lot of crazy stuff. Oh my God. Okay, 10 plus 20. I would like to actually tab this off so it doesn't seem like an input or something. Maybe not. Hold on a sec. Actually, it's fine because we have the prompt anyway, so it's fine. Although I would like maybe to tab this up. I don't know. I guess maybe let's try it. Yeah, I guess let's try it. So where to put it exactly? Split 1, split 2, blah, 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 blah. There we go. Okay, so here. Okay, let's try to add the tab there. Let's see how it looks. Not here, in the terminal. Cargo R, and let's say 10, 20 plus. Boom. As you can see, it just says 10 plus 20 equal 30, and then the result is here. Interesting. Okay, nice. Can also do something cool, which is just to say equal to result. Just like that. Equal to result. Okay. And for the error messages, maybe we can say error. Error. You're free to do whatever you want. This is just, like... So yeah. Now, let's actually go back to terminal. Cargo R, 1020 plus 30. There you go. I don't know if I like to tab the results or not. I don't know. I guess so. I guess let's try that out. For the errors, what about the errors? Should we tab them out or no? Probably not. Fine, probably not. Let's just say the T here, tab here, boom. I mean, let's go terminal. 1020 plus, as you can see, this is what we get. You say plus, error, 2 operands are needed before plus. Which is quite lovely. So, is there anything other than that that we'd like to handle? Yeah, pretty much we have no other in wraps, looks like, which is lovely, which means we have handled all the errors, maybe. Binding error is never used. What do you mean? Never used? What do you mean? Error, read line, error. Huh. Some reason this is not never used. Interesting. Alright. Just to, I don't know. What if we remove this? Match must be exhausted. Oh man, this is crazy. Okay. Anyway, I think we're done at this point. Yeah, I think we're done. We can add one single thing, which would be lovely to see. Let's see. 1020 plus, for example. I would actually, let's add some more. So if I have something like this. Oh, plus. Actually interesting. I have to handle such a thing where like the stack, we can also do something crazy, which is just to say 10, 20, and then plus. And then it should give us a result. Well, should we do that or no? Because in fact, if we don't do this, then when such a thing happens where the stack is still not empty, like it's basically when you pop the result, the stack should be empty. Otherwise, you should error, because in fact, if you don't error, then the user won't know that his results he's missing something, right? So, alright, interesting. Actually, I'm just gonna stay on the safe path, and whenever the user do something like this, where there is an extra operand, I'm just gonna tell him that. Maybe I'm gonna actually just notify him, right, that he missed something. Otherwise, let's go back to our first thing that I want to say about colorization. So basically what I want to do is to, for example, 50 colorize it, 50 colorize it, right? So basically colorize the values that are old, right? Something like that, I don't know. Or maybe new values or something like that. I don't know which library to use to colorize. Rust? I believe there was a library called colorize. I guess. Actually, there is a library called colored. I don't know what's that. Coloring terminals so simple, you already know how to do it. All right, sure, fine. Let's copy. Let's try it out. But of course, we gotta add that up. Although, let me check one thing. Can I? Hold on a second. The repository. I just want to check real quick the repo. How is it? If there's any trouble with it. June 29th. Looks like it's still maintained to some extent, so that is nice. All right, I believe we're fine. Not sure, but yeah. Anyway, so after you do that, what you do, you can say dot on blue dot red dot true color dot on true color dot bold. Oh yeah. Dot italic dot yellow dot blue dot red. Interesting stuff. Let's try it out. Although dot yellow string type yellow color blue green. Well, we have a little problem. Is that it doesn't work on formats. It only works on strings directly, which sucks. All right, interesting. Is there any other kind of all right, let's see if there's something else that would help. Let's actually go to crates.io. Crates.io. Call. There is this colorize, I remember, which might be nice. Yeah, and see, that's exactly, I guess, what I need. But let's see. Set some global errors. Green underline, yellow B. That's not what I need. ANSI color to set the global foreground. To colorize. Not really. Well, that sucks. These things are reset to the default at the end. Interesting. So no, I'm not gonna use colorize here. Procs variantly, blah 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 blah. Professional color schemes, blah 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 blah. Okay, so I'm just gonna use colored anyways. I'm gonna see how I can deal with this. Gonna suck. Word dot red dot blue on blue, blah 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 blah. Operand 1, operand 2. Operand 2 stack dot pop. Stack dot pop. 2 operand 2 equal result. Operand 2 operand 1. So I guess I want to color operand 2 and I want to color result, but how to do that? All right. This is not gonna be simple. Actually, let's just leave that for now. But we can color some stuff. 2 operands are needed before, 1 operand is needed before. We can colorize the errors. So, for example, here error message. Can just go ahead maybe and say dot blue or dot red, I guess. Does that make sense? I think so. What? Right, interesting. Right. Expected a comma. Did I imported colored? I don't remember if I did. No, I didn't. So terminal cargo add colored. There we go. Made rs. Boom, boom, boom. Now let's try if this works. No, it doesn't work. I believe that might be because this is you know, because it's a macro. Let's try right now. Although we need to do the same thing here too. There we go. Now plus error 2 operands are needed before plus. Oh, actually, let's try in the terminal, not here. Terminal, oh my god, cargo R plus, there we go, error 2 operands are needed before plus. Let's go, nice, 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 lovely. Oh yeah, that is nice. Are needed before plus, one operand is needed before plus. All right, interesting indeed, interesting. Okay. Although maybe I'd like to actually, instead of doing it this way, I'd like to put the color from the function itself, I guess. Maybe, I don't know. Cannot be parsed into a number. Okay, so can I say this? Dot red, dot red. Oh, no. Hold on a second. No, that's not gonna work out. Yeah, that's not gonna work out. If I want it to work out, then I gotta say the in-map or like the in-map error, then color it up. But it's just so messed up. Just so messed up. Oh man. Yeah, so messed up. All right, fine. I'm just gonna leave it like this. Error message dot red. But that also means that we can only have two colors, red and stuff like that. But yeah. Next up, though, we can say if, here's the case. Actually, I shouldn't do it this way. All right, so if stack.len, so if the length of the stack is greater than 1, then we're basically gonna say print line skipped an operand. Skipped the operand, and we're gonna tell, well, if we tell it, then we gotta tell it some, Okay, let's try. Skipped the operand, or operands, basically. And which operands? Well, let's see. Stack, and I believe I can do something like this. Is that the case? T doesn't implement debug. Can I just do? Can you just do it? Let me just try to run this. Oh yeah, interesting. I gotta actually give it the reference. Oh yeah, plus std fmt display debug. Let's try that out, I guess. T. Run. Yeah, it works right now. So that means that if I say something like this, that's gonna tell me that it skipped the operand or operands 20 and 30. Actually, not that way. Okay, hold on a second. Not that way. Where is the stack or whatever it is? Instead of 1, here we're gonna say stack.len -1. Because basically, in fact, we don't want to take the last ones. I want to take this ones, okay? So let's try again. 10 and 20. As you can see, skip the operands 10 and 20 is the result. Just so the user know exactly that we actually have skipped those guys, which is interesting. So the other thing that I would like to do is to color it, yellow. It's like a warning. I don't know, but is that possible though? Hold on. Skip the operands. The yellow. How do I do that? Well, it sucks that I gotta. Oh my god. So, all right. At the end of the day, I gotta do it. It's gonna suck, but let s, for example, equal. So this is how you do it. You just format first. This is what I actually avoided before, but anyway, we gotta do it in either way. So print line s, comma, or in fact, this, and then comma s dot. Now I can say yellow without any problem. So basically I format first, then I color the result string. Okay, so I'm not gonna use this. I'm gonna use the, oh my god, no. I'm gonna use the terminal. Cargo R. Now if I say 1020, as you can see, skip the operand 10 and it's in yellow. 10, 20, 30. There you go. If I say plus, as you can see right now, it didn't say that it skipped the operand 20 because it's already used. So that is quite amazing. If I say this, no problem. If I say plus, oh, 2 operands are needed before plus, and stuff like that. So that is lovely. Okay, so I'm gonna upload this into GitHub, I believe, and then I'm just gonna give you the link in the description below. And by the way, the channel, I have actually disabled all ads from the channel because of a lot of reasons. But I may add the option to donate in the future, or maybe become a member through YouTube or something like that. Either way, it's just for me here to share with you this knowledge. And make sure to subscribe if you like the video. If you have any suggestions or whatever, put it in the comment section. And so that's pretty much it. If you want me to continue this project or like, you know, start a new project, then let me know. So yeah, goodbye everyone. See you later. Goodbye.